So this question is asking for the area under a function f of x from 0 to infinity. So it's a definite integral, but it's a piecewise integral in the sense that f of x isn't one continuous function, but it's defined in 3 different regions. So for negative x, f of x is 0, and then from 0 to 2, it's this rising exponential, and then from 2 onwards, it's a decaying exponential. So e squared minus 1, that's just a constant, and it's multiplied by e to the minus x, so that's a decaying exponential. So to find the area, to find the integration from 0 to infinity f of x dx, because this is a piecewise function, or a function that's defined in segments or in phases, then we would add the integral from 0 to 2 f of x dx plus the integral from 2 to infinity f of x dx. So that would cover the entire region between 0 and infinity. So from 0 to 2, and then from 2 to infinity. And now we'd simply substitute the expression for f of x given in the question. So it's 1 minus e to the power minus x dx from 0 to 2 plus e squared minus 1 e to the negative x dx from 2 to infinity. So the integral of 1 is simply x, and the integral of e to the minus x is e to the minus x divided by minus 1. So that would change this negative sign to a positive. And then you have your limits of integration from 0 to 2. Then we would add. Now, this is a constant. It's really confusing to have a constant inside the integration, so we might as well just pretend that constant is outside the integral. So now we have e squared minus 1 multiplied by the integral of e to the negative x is simply e to the negative x. Now we would say divide by 1, but it's easier to go back and change this positive to a negative, and then put in the limits of the integration from 2 to infinity. So that integrates to that. So now we can simply substitute the limits. So if we substitute a 2 instead of x, and instead of x there, we have 2 plus e to the negative 2 minus, now we do the same, this time we substitute 0 instead of x. So it's minus 0 plus e to the power 0. Then we've got a minus e squared minus 1 times e to the minus infinity. So I'm substituting the upper limit instead of x. Then we subtract after substituting the lower limit. So e to the minus x minus e to the power 2. So now we can simplify, so that e to the power 0 is just 1. E to the power minus infinity is 0. If you're in any doubt about that, so e to the minus infinity is 1 over e to the infinity, which is pretty much 1 over infinity, which we can replace with a 0. So now if you simplify that, you end up with 2 plus e to the minus 2 plus 1 minus. Now I think we're going to need to expand these brackets, so we're going to multiply the e squared by e to the negative 2, and then multiply negative 1 by the same. So that will give me negative is positive, e to the power 2 minus 2. Then we've got a negative, so that's negative, e to the minus 2. So again, that simplifies to 1, and that cancels with that, and you've got a 2 and a 1, so that gives you 2 minus 1 plus 1 equals 2. So I guess that would be the answer. That would be the area under this piecewise integration. So you've got a rising exponential and a decaying exponential, and the total area is equal to 2. That's the area from 0 to infinity.